Hi everybody and welcome. In today's video we are going to be talking about the graphs of parabolas and specifically within those graphs the vertex and axis of symmetry. So after watching today's video, our goal is to be able to identify visually and also to calculate by hand a vertex and an axis of symmetry on the graph of a parabola. So we've talked about the vertex before and we had to identify those in our previous lessons, but today we're going to talk about something a little bit new for us, which is the axis of symmetry. So an axis of symmetry is a line that divides an object into two equal halves. So this is also something in a real world application. It's actually a traditional sign of beauty. If you look at a face and you can basically put a line straight down the middle of it, and both of those faces are a perfect reflection of each other, then that's a traditionally objective way to measure beauty. And kind of a weird reference, but in popular culture, it's a way that it goes through. So if you were to take Winnie's face and you were to divide it into two equal parts, what you would see is a perfect axis of symmetry going down the middle, because the left side is a reflection of the right, because Winnie is an objectively perfect dog and the symbol of beauty in 7-pound chihuahuas. But a second way that we can look at this is also if we're looking at the graphs of a parabola. So if we were to see a parabola over here like this, we would just take a line basically straight down the center of it, and we would see that this line would be an exact reflection on the left and right side if I had drawn it perfectly parabolically. But in this case, my freehand is not perfect, but the idea is that the left side and the right side of this line are an exact reflection of each other. So that is what helps us identify the axis of symmetry. If a parabola is facing straight up or straight down, we're going to be able to calculate the axis of symmetry as an x equals equation. So because these are this way, we can see that a line straight up and straight down is an x equals form. So if this is at the point 4, for example, this line would come at x equals 4. If we are calculating this by hand, instead of looking at it visually on a graph and we're not sure exactly where that center lies, we can actually use our formula x equals negative b over 2a. So in our standard form of a parabola of a quadratic, we could identify a, b, and c, plug in b, plug in a, and we would have our axis of symmetry already solved for us. So we're going to take a look at this function here, x squared plus 2x minus 1, basically using technology to graph it for us. And we're going to see if we can determine any of those things in terms of axis of symmetry, vertex, just by looking at it. So here we go, x equals, or sorry, y equals x, I'm terrible at using Desmos, 2x, plus 1, there we go. So conveniently Desmos is thinking ahead for us, it's helping us out. So if we hover over each of these points, it's going to tell us, okay, so there is the minimum value, the vertex of our parabola at -1, 2, our y-intercept at 0, -1, an x-intercept at -2.414, and also at 0.414. So it looks like on this one, if we were to calculate it out, we'd have to use the quadratic formula, and we'd get a messy decimal for those x-intercepts, but the good news is for our vertex and for our axis of symmetry going straight up and straight down on this graph, that we luckily are able to draw that line. So back to our notes here, we can see that we have our graph. So we'll just redraw this one quickly here, -1, -2. We had 0, -1. And I'll pause at the end to make sure we can get this in. We had about 0.4, -2.4. And then from here, we can more or less just connect our dots. So again, looking at this at some of the points that we are trying to identify, if we're looking for that perfect axis of symmetry going straight up and straight down, we're going through that line, x equals -1. So if we go down and we're starting to identify some of our points here, we can see x equals -1. Second, for our vertex, we also see the vertex has an x value of -1. And based off of the graph, we're able to see that it has a y value of -2. Now, if you don't have a graph handy, what we're actually allowed to do here is we can do y equals x squared plus 2x minus 1, and just take our x value, which we already solved for, -1, and plug that in. So in this case, we'd end up with y equals 1 minus 2 minus 1, which ends up, punch that into the calculator as just -2. So y equals -2, and that's how we get y equals -2 there. To also double check by hand our axis of symmetry, we know that A, B, and C based off this graph are 1, 2, and -1. So again, A equals 1 comes from our x term, B equals 2 comes from our middle term, and C equals -1 comes from our constant. So that's where each of those come from. So now we can plug that into our formula of -b over 2a. So we identified b as 2, and we identified a as 1. So if we punch this into our calculator again, we get -2, and then 2 times 1 is 2 on the bottom. So -2 divided by 2, remember fraction bars are just division signs. We end up with -1, and again, that is our x value for that formula. So by doing this, we've just identified that we can calculate this by hand. We can also check our calculations by looking at a graph, but basically both of these ways work, and this also helps us in identifying when we're looking at our quadratic here, at our parabola. So the last thing for now that we're going to take a quick look at here is if it opens up or down. So this one, it's like a bowl. It opens up. And I think that's actually all for this one. So the nice thing here, opening up, we can use this using our a value. So if a is greater than 0, it's a fancy way of saying it's positive, then we're going to see a graph that opens up. If a is less than 0, so if you see a -a, then we know that it opens down. So let's calculate this by hand for the second one, and then we'll take a look and see if what we calculated by hand matches what we have in our graph. So A, B, and C, start off with that. We see that A is -3, so we're going to say that's going to open down because it's negative. For our axis of symmetry, we'll actually skip down there. We get -b over 2a. So in this case, b is -6, a is -3. So on top, those are two negatives, which is why it's really important that we put those parentheses when we're plugging into our formula. So two negatives do cancel to give us +6. And then on the bottom, this is multiplication. So be careful, 2 times -3. We're not adding these together. So we'll get -6 on the bottom. And again, we'll get -1 as our axis of symmetry. So the next piece that we'll plug in is our vertex. So for the vertex, we again plug in to solve for y. And we have to make sure we actually plug into the right formula. So -3x squared minus 6x plus 3. And for these, again, very, very important to make sure we're using parentheses, especially when we're dealing with a lot of negatives. So in this case, x is -1, so we want to make sure that we are plugging that in. And following our order of operations. So parentheses, then exponents, then multiplication, working through our way there. Remember, don't trust your calculator. Plugging in negative squared into your calculator, depending on what you're using, might not always work out. So if we do this correctly in our calculator, -1 squared is just 1. And then we'll want to work our way through the rest of the question. So our next step from here, we'll multiply these two terms, and we will multiply these two terms. So -3 times 1 is -3. We've got +6 plus 3, and we should get an answer of y equals +6 here. So the vertex is not y equals positive 6, it's x and y together. So -1 for x and positive 6 for y. So calculating these out by hand, let's again double check this with the graph, see how this comes out. So -3x squared minus 6x plus 3. Okay, so the first thing we said was that this opens down. Our vertex is at -1, positive 6, and our axis of symmetry is at -1. So we said it opens down, -1, positive 6, axis of symmetry at -1. So all of our calculations work, which is great. So that is how we do it in standard form. And that is one of the ways that we can take a look through what we can graph a parabola. The second way that we can take a look at this is, instead of standard form, what we were working on last week with completing the square, is vertex form. So this is a method of defining a quadratic function using the vertex. So in this definition, we are going to identify vertex form as y equals a times x minus h all squared plus k, where we have a vertex at h comma k. Now remember, k goes directly down without any change, but when we bring h down, we flip our sign. So we worked on this a little bit last week with identifying the vertex, so just a quick reminder there. In contrast, what we worked with for about a month before jumping into our vertex form was standard form, which was ax squared plus bx plus c. So make sure we understand that these talk about exactly the same thing, they just represent it in a different way. One uses a, b, and c, the other one uses the vertex. So taking a look at our first function here, we'll first punch it into Desmos, take a look what the graph is, and then we'll go through how do we calculate it by hand. So our function was x plus 1 squared minus 2. So it tells us we have a vertex at -1, comma -2, which makes sense if we look at our h and k values. We change the 1, we keep the -2. And then again, looking at our x-intercepts and looking at our same y-intercept here. So a remarkably similar graph to what we had for the first page, just written in a different form. So again, just drawing this out. And showing a lot of the same things here, just doing it in a different way. So once more, if we're going through our calculations by hand, we're going to want to identify our h and our k. So for our vertex, for h, we just want to flip its sign, and then for k, we'll keep it exactly the same. The nice thing about axis of symmetry is it's simply the x value of our vertex. So x is just -1. And then our last piece here, if it opens up or down, this is actually the same as before. If a is greater than 0, it opens up, and if a is less than 0, once more, it opens down. So in this case, our a value is just that number that's hiding in front of the function. So we don't see a number written here, but we know that if there's nothing written, it's just a 1. So it is a positive 1 in this case, which is greater than 0. So we do see that this one opens up. So working our way through for the second function, a very similar process. We'll identify what our a value is first. In this case, our a value is negative, so we know that this one should open down. Our vertex we'll identify again, highlighting first, writing it second. So the opposite of our blue, which is positive 4, we keep our yellow exactly the same, and our axis of symmetry is just exactly what our x value of our vertex is. So as you can see, if we're graphing, Putting it in vertex form saves a whole lot of time because you can identify so many things right away. If you scroll up, look at all these calculations that we had to do if we're just trying to find our vertex, right? This is a lot of work compared to if you just scroll down, just doing a little bit of highlighting and identifying what we need to do from there. So pros and cons to both approaches. I'd say vertex form, like we did completing the square last week, it's a little bit tricky to get into vertex form, but once it's there, your life is made a lot easier. So that is today's video. As always, if you have questions, let us know. There are some practice questions coming up next. So you're ready to get started on those, and hope you have a good time doing those. Let us know again. Email, raise your hand, ask questions, any of those things. We are here to help